Welcome back, everyone, to another deep dive. Today, we're going to check out this really cool uh, star called FU Orionis.
Ooh, that's a fun name.
Yeah, it is, huh?
Definitely memorable.
And we've got this article from space.com that details some observations that were done by the Hubble telescope recently.
Yeah, it's pretty amazing stuff they found.
Yeah, so why don't you tell us a little bit about this FU Orionis?
Okay, well, it's pretty far away, 360 light years away,
Wow.
and much hotter than our sun, like 3 times hotter.
Wow.
And it's surrounded by this disk of gas and dust,
Okay.
kind of like the kind that normally forms planets.
Right.
But this star is a little bit different. It's actively feeding on the disk.
So it's like a cosmic glutton?
Yeah, exactly, devouring its own planetary nursery.
That's pretty wild.
Yeah, and that's not even the most interesting part.
Oh, there's more.
There's more.
Okay, I'm intrigued.
So, FU Orionis is classified as a T Tauri star,
Okay.
which is a type of young star known for its active disk and kind of its energetic outbursts.
Okay, so like a star going through its teenage phase, lots of drama,
Good
lots
grief.
of energy.
Exactly, lots of drama.
Okay, so but you're saying FU Orionis is even more unusual than the typical T Tauri star.
Yeah, think of it this way. If most T Tauri stars are like teenagers going through a growth spurt,
Uh-huh.
FU Orionis is having a full-blown meltdown.
Oh,
Its disk is like incredibly unstable with all this gas and dust just spiraling into the star at this alarming rate.
that does not sound good.
No, it's very chaotic.
So what's causing all this chaos?
Well, there's a couple leading theories.
Okay.
One is that just the sheer amount of material in the disk
Okay.
is creating like an imbalance
Yeah.
and leading to all this instability.
Okay.
Another possibility is that FU Orionis has a hidden companion,
Like a secret sibling causing trouble.
exactly like a secret sibling.
Okay, so this hidden companion.
It would be another star, basically,
Yeah.
and its gravity would be kind of wreaking havoc on the disk.
Oh, wow. Okay, so that's a possibility too.
Yeah, and I'm guessing you're probably thinking all this instability leads to those dramatic outbursts FU Orionis is known for.
Yeah, that's exactly what I was thinking, because it just
Yeah.
seems like with all this chaos, something's got to give.
Right.
So tell me about these outbursts.
Okay, well, we're not talking about like small fluctuations in brightness here. Like
Yeah.
back in 1936, FU Orionis went through this outburst where it became 100 times brighter
Bro,
over just a few months.
100 times brighter in a few months. That's insane.
It's crazy, right?
Stars don't normally change their brightness that quickly unless they're like going supernova.
Yeah, you're right. It's very unusual.
So what's going on there?
Well, that's what initially puzzled astronomers.
I bet.
But they eventually figured out that the intense light wasn't coming from the star itself.
Okay.
It was coming from all that superheated material in that crazy disk.
Oh, so it's like the supporting cast stealing the spotlight from the lead actor.
Exactly.
All that gas and dust just swirling inward, just creating this huge light show.
Yeah, 100 times brighter than the star itself.
And this outburst has been going on for almost a century.
It has, but it has been dimming over the decades.
Yeah.
But that disk, it's still glowing, like, fiercely.
Okay.
And that brings us to what Hubble recently observed.
Ah, yes. The Hubble telescope always giving us these amazing glimpses into these events.
Right.
So what did Hubble reveal about all this drama?
This is where things get really mind-blowing.
Okay, hit me.
So they used Hubble's ultraviolet instruments
Mm-hmm.
to zoom in on the region where FU Orionis's disk is touching the surface.
Okay.
And they found the scorching inferno reaching 16,000 Kelvin.
16,000 Kelvin. That's 3 times hotter than the surface of our sun.
I know, it's crazy hot.
What could possibly generate that kind of heat?
Yeah, so that's the question that has everyone buzzing.
I bet.
You see, the prevailing theory was that the heat was coming from all that material just falling onto the star, because of gravity.
Right, makes sense.
But this new research led by astronomer Adolfo Carvalho is challenging that assumption.
Oh, okay. So if it's not just gravity at play, what else could be going on?
Well, their theory is that the extreme heat is caused by this massive shockwave.
A shockwave.
Yeah, think of it as like a cosmic sonic boom.
Go.
So imagine the edge of that disk spinning at these incredible speeds, and it's slamming into the star's surface.
Oh,
And the star's surface is rotating much more slowly.
okay.
So that collision is generating the shockwave
Wow.
that's releasing just tremendous amounts of energy as heat and light.
So it's not just like a gentle rain of material. It's like a cosmic tsunami crashing onto the star.
Right, exactly.
This shockwave theory definitely explains those extreme temperatures.
Yeah, it's pretty wild.
But I'm curious, what does all this mean for the possibility of planets forming around FU Orionis.
Right.
I mean, it doesn't sound like the most hospitable environment.
Yeah, you're right. If we're talking about rocky planets like Earth or Mars,
Yeah.
their chances of forming close to FU Orionis are pretty much nil.
Yeah, I can see why they either get sucked into the star's gravitational pull
Right.
or get completely fried by all that radiation.
Exactly. It's definitely not a place where life as we know it could thrive.
Right.
But what about planets forming further out in the disk?
Ooh, now you've piqued my curiosity.
It's where things get really interesting.
Hold on, you're going to have to tell me more about that in part 2 of this deep dive.
So these planets forming further out, they're
Mhm.
not just dodging, the intense radiation and heat.
Right.
They're also being exposed to this really unique mix of chemicals
Okay.
all churned up by these, crazy outbursts.
So instead of the usual planetary ingredients, they're getting a cosmic cocktail shaken, not stirred by FU Orionis's tantrums.
Yeah, exactly.
That's pretty wild. So what would that do to a planet?
Well, it could lead to planets with compositions and atmospheres that are like nothing we've ever seen.
Okay.
Imagine planets rich in elements that are super rare in our solar system,
Uh-huh.
or planets with geological features that we just don't even understand yet.
So FU Orionis is like conducting its own grand experiment in planetary formation.
Yeah, and we have a front row seat.
That's so cool. And all this is happening like right now.
Yeah, as we speak. Although we can't observe these planets directly just yet,
Right.
the conditions around FU Orionis suggest that planet formation is happening.
But it's probably a very unusual kind of planet formation.
Yeah, definitely.
So we could be talking about planets that are not just different, but like downright bizarre.
Oh, absolutely.
What kind of strange worlds could come out of this chaotic environment?
Well, imagine like gas giants
Yeah.
with these swirling, chaotic atmospheres
Uh-huh.
colored by these exotic elements,
Okay.
or rocky planets with compositions that just break all our, preconceived notions of planetary science.
It's like looking into a cosmic kaleidoscope
Yeah.
and seeing all these worlds that are both beautiful and just bewildering.
I know, it really makes you realize how much we still don't know about the universe.
It really does. It's a very humbling thought.
And the fact that a star like FU Orionis can even exist, throwing these cosmic tantrums
Yeah.
and potentially creating these strange new worlds,
Uh-huh.
it just opens up the possibilities for what's out there.
Yeah, it really does. It makes our little solar system seem pretty tame in comparison.
Yeah, or orbiting this calm and stable star.
Right.
And then you have these stars like FU Orionis just showing us that the universe is way more diverse and unpredictable.
It really is awe-inspiring.
And this discovery about the shockwave and the extreme temperatures,
Yeah.
it has implications that go way beyond FU Orionis.
What do you mean?
Well, it makes us question our understanding of other T Tauri stars, too.
Okay.
Are we seeing similar processes happening around other stars?
So this one observation is like opening a door to a whole new realm of question
Exactly.
about star and planet formation.
And it just highlights how important it is to keep observing and studying these, young dynamic systems.
Right.
Who knows what other secrets they hold?
Well, speaking of secrets, there's one question that's been swirling in my mind ever since we started talking about these, bizarre planets.
Yo, yeah, what's that?
Could they maybe support some form of life?
Ooh, that's a big one.
I know it's a bit out there,
Yeah.
but life as we know it probably wouldn't stand a chance.
Right.
But what about life that's evolved to thrive in these extreme conditions?
That's a question that astrobiologists are really grappling with right now.
I bet.
We tend to define life based on our own very limited experience here on Earth.
Yeah,
But what if life elsewhere took a totally different path?
right.
What if it thrives on energy sources that we would consider hostile?
Or even impossible.
Exactly. So it's like we need to expand our definition of life itself.
To encompass this like sheer diversity of the universe.
You got it.
That's really cool. I like that.
And that's the beauty of exploring the cosmos.
Yeah.
It challenges our assumptions,
Uh-huh.
pushes the boundaries of our knowledge,
Yeah.
and it forces us to reconsider what we think we know.
Well, I think it's safe to say that FU Orionis has definitely challenged our assumptions today.
It has.
And it's left me with this sense of wonder and excitement about all the possibilities out there.
Yeah. It's amazing to think that we might actually discover some completely new forms of life out there.
I know, it's crazy.
And they might be shaped by these crazy conditions in these chaotic systems.
Shaped by chaos.
Yeah,
It really highlights just how vast and diverse the universe is.
it does.
FU Orionis is just one example.
Right.
Who knows what other strange and wonderful systems are out there just waiting to be discovered?
It really makes you realize how much we still have to learn.
It does.
Like our understanding of planet formation,
Right.
the conditions that can support life, it's all constantly evolving as we make these new discoveries.
Absolutely. It's a never-ending journey.
Speaking of pushing boundaries, this whole conversation has been a real eye-opener for me.
Oh, yeah.
I mean, I knew that Tauri stars were energetic,
Uh-huh.
but I never imagined this level of drama unfolding around FU Orionis. It's a wild one for sure. It
Yeah.
just goes to show that even familiar objects like stars can hold these incredible surprises.
Yeah.
And the fact that we can study these events in such detail thanks to instruments like Hubble.
It's amazing.
Pretty remarkable.
It's like having a front row seat to the most spectacular show in the universe.
I know, right?
And with new telescopes like James Webb coming online,
Oh, yeah.
we're going to have even clearer views of these cosmic wonders.
The future of astronomy is incredibly exciting.
It is.
We're on the verge of making discoveries that will fundamentally change how we understand the universe and our place in it.
So for all of you listening out there, why should you care about a temperamental star throwing a tantrum thousands of light years away?
Well, it's not just about a single star.
Yep.
It's about broadening our perspective, you know?
Yeah.
FU Orionis shows us that the universe is full of surprises,
Okay.
that our current models and assumptions might be too limited.
Right.
It encourages us to question, to explore, to never stop being curious.
FU Orionis is a reminder that there's so much more out there than we can even imagine.
It really is.
Planets that defy our understanding.
Totally.
Stars that behave in unexpected ways.
Mm-hmm.
And maybe even life as we don't know it.
It's mind-boggling.
It's a call to keep looking up, keep asking questions, and to keep exploring this vast and mysterious cosmos.
Couldn't have said it better myself.
This deep dive has been a wild ride.
It has been.
From a star devouring its disk to the possibility of bizarre exotic planets and the implications for life as we know it.
A lot to unpack.
Yeah, it's been a journey through some of the most fascinating and thought-provoking ideas in astronomy.
And it all started with a single article about a fascinating observation.
Yeah.
It just goes to show how a deep dive into a specific topic can lead to these broader insights and a deeper appreciation for the universe we live in.
And that's what these deep dives are all about.
Right.
We take a stack of your sources and really break them down, extract those golden nuggets of knowledge and insight.
Like a cosmic treasure hunt.
Exactly, and with just enough humor to keep you hooked.
Well, hopefully.
So as we wrap up our deep dive into the world of FU Orionis, we leave you with this final thought.
Okay.
We've talked about the possibility of planets forming around this chaotic star.
Right.
But what if those planets are even stranger than we can currently conceive?
Ooh.
What if they have properties or characteristics that we haven't even begun to imagine?
That would be amazing.
What might life be like on a world shaped by such an energetic and unpredictable star?
It's definitely something to ponder.
It is a question worth pondering as we continue to explore the endless wonders of the universe. Until next time, keep looking up and keep diving deep.